Hello everyone. My paper was called Deep Learning in Image and Medical Image Analysis. The paper was written by Chan, Samala, Hajaski, and Zhao. This was a part of the Department of Radiology and from the University of Michigan. Overall, what the paper was about a computer-aided diagnosis tool. This essentially was a second opinion to assist radiologists in image interpretation. The first application of this was on mammograms, and this was approved in 1998 as the first approval of a commercial CAD system for mammograms or mammography. The only limitation these colleagues had was it was rarely used in a clinic, and it didn't have a very strong diagnostic accuracy and workflow efficiency on the time it was created. Um, so what is a CAD? A CAD are systems that are developed with a machine learning method. Um, Before, CAD uses conventional machine learning approaches in medical images to analyze image, to recognize disease patterns and distinguish between different structures in the image. Classes could be normal or abnormal or malignant or benign, as stated in the paper. So here is a typical machine learning process. Um, what the laboratory people will do is they will grab an image, they will divide the images into its specific components. This is normally typical based on which kind of machine learning model you're doing. And then you'll apply up some sort of model, then you'll test the classification, and then you'll quantify its prevalence. So in the paper, when they were using the conventional machine learning methods, the design was based upon domain knowledge for image processing and feature extraction. So essentially breaking down the image and getting the right features for the model. And feature effectiveness was dependent again on domain knowledge, capability of mathematical formulations, and also image analysis techniques such as making it more brighter, segmenting the picture, or changing the background. So recently, the authors have indicated a new method to analyze pictures or image processing, and that is called DCNN, or Deep Convolutional Neural Networks. Deep learning has become the state-of-the-art machine learning method. The reason for this is that it automatically extracts relevant features, discovers feature representation, and also automatic learning processes. So the author indicated that deep learning is a very ubiquitous kind of platform because it could process a million images simultaneously without any kind of intervention, and which is almost impossible right now for a regular human person to do that. So again, using these DCNNs for image processing could be very beneficial for the medical image processing data sets. DCNN was enabled by some neural network techniques, which the author has indicated. Some of the techniques were layer-wise unsupervised pre-training, followed by supervised fine-tuning, the use of the ReLU activation function compared to the normal sigmoid function, the essentially the pooling of the nodes, and batch normalization. All of these techniques allowed for the DCNN to come about. So finally, I wanted to close on some of the final remarks the author had. So the challenges we are facing this deep learning for CAD is no CAD system with the new techniques have been tested in a large based clinical trial besides the one performed in the 90s on mammograms. Another challenge is to develop performance standards, acceptance trainings for the users, and also the QA procedures have to be established for each type of CAD-based system. So that could be challenging in the future if we were to implement this. Sorry, my computer has a mind of its own. Um, the CAD recommendation has to be interpreted by the clinicians to allow for informed decisions. So not only do we have to train the techs who are, implementing this, but we also have to train the doctors who could use these decision systems made by the computational models, which could be challenging as well. The final thing that's the most important is workflow efficiency and costs are a major consideration. The authors have stated if the cost outweighs the benefit, it will never come to light in the medical field. And also, if the workflow takes a long time, it will also not be a feasible method for the clinicians as a diagnostic tool. But nonetheless, this was a great paper. It provided me a great basis and also some key information on my model and my paper that I'm going to do in the future. And that is all I had.